Dear learners, greetings of the day. In this session, we are going to see about demand paging, an important concept in the operating systems. Myself, Devi Arockia Vanitha, working as Associate Professor of Computer Science in the Standard Fireworks Rajaratnam College for Women, Sivakasi. In the modern computer system, the important resources are the processor and the memory. The memory is an important concept to be taken care of in the modern computer system. So, to take care of that, we should know about the memory first of all. Memory is a large array of bytes or words. Each byte is having its own address. And there are two types of addresses. One is logical address, another one is physical address. The address generated by the CPU is called the logical address, and that is generated by the memory management unit is called the physical address. The logical address will be mapped onto the physical address with the help of a hardware device called memory management unit. And what is the goal behind the memory management strategies? Or in another way, we can ask, why should I manage the memory? There are two types of memory. One is primary memory, another one is secondary memory. A program to get executed, it should be loaded into the primary memory first, and then it will be executed by the processor. And all the other times, it will be retained in the secondary memory. So, to achieve multi-programming, what the operating system tries to do is, it tries to bring in more processes in the main memory at the same time. And this concept is called multi-programming. So, to achieve a higher level of multi-programming, the OS tries to bring in the entire process into the memory before execution. But the size of the primary memory is limited, as we all know. All the data will be stored in the secondary storage memory, that is called backing store. So, while managing memory, the problem here is the entire process, that is more than one processes, cannot be brought into the main memory at the same time. So, what is the remedy? So, the remedy is, if there is a possibility to execute partially loaded program, instead of loading all the instructions of the program at the same time, we can load it based on the requirement, one after another. So, if that partial loading ability is present means, then what we can do? One, the program has no constraint because of the size of the physical memory. Even though the physical memory is small, we can load more programs into the main memory. Second one, each program takes less memory while running because of the limited number of instructions present in the main memory, and we can run multiple programs simultaneously. Third one, we require less I/O. So, that is an important one. So, these are all the possible advantages if we are having the access of partial loaded program. So, with these things, we should get into the mechanism that achieves the concept. It is a buzzword in computer science called virtual memory, a memory which separates the user logical memory from physical memory. The virtual memory concepts allows the user to load the program partially into the main memory. So, see this diagram. On the right hand side, we are having the backing store, and next to the backing store is the physical memory. The physical memory is divided in two frames, and next to that we are having a page table. A page table consists of two entries, page number and the corresponding frame number. And finally, we are having a virtual memory which is divided into pages. Look into the diagram once again. The virtual memory seems to be larger than the actual physical memory, so it gives an illusion to the users that more number of programs can be brought into the main memory. With this introduction, we are moving to the implementation of virtual memory. The virtual memory can be implemented using two mechanisms. One is by demand paging, another one is by demand segmentation, and in this session we are going to see only about demand paging. So what is demand paging? That is the next question. Before getting on to the technical topic, I want to share a real life analogy of demand paging. A customer went to a shop and asked for a specific item, and the shopkeeper checked the stocks, and he recognized that the item is not available in the shop, but it is available at the store, the warehouse of the store. Then the shopkeeper asked the customer to wait for a while, and he brought into the item into the shop. This is how the real demand paging also works. The OS checks for a particular page when it is required by the CPU. CPU can be related with the customer and the OS can be related with the storekeeper. The CPU asks for a page and the page is not available in the main memory, and it is available in the secondary memory. So it has to be brought into the main memory with the help of OS. So with demand paging, we can achieve partial loading of programs and we can implement the concept of virtual memory. What are all the benefits or how it functions? One, either we can bring the total process into the memory at the loading time itself, but when it is a multi-programming concept, this is not recommended. Otherwise, a page is brought into the memory only when it is required. And the third one is an important one. When a page is needed, a reference is made to it. And the reference shows that whether the page is present in the main memory or in the secondary memory. If it is in the primary memory, it will be executed by the CPU. Otherwise, it will be brought into from the secondary memory. And these swapping, moving the page from the main memory to the secondary memory and later on from the secondary memory into the primary memory, is carried out with the help of a lazy swapper. So the swapping is an important job which is carried out during demand paging. Hope it's clear. This is how the swapping works. See the diagram here. In the main memory, there are two programs, program A and program B. Program B requires 3 pages, 17, 18 and 19. To bring in those pages, what the lazy swapper does is, it swaps out the pages 4, 5, 6 and 7 of program A. And this is the overloading work which is carried out by demand paging. And with swapping, the pager guesses which pages will be used before swapping out again. If I am bringing in page 5, 6, 7, 8 instead of the other pages, why should I swap that pages? That is the question here. So before replacement, the pager has to guess which pages will be used, and this guessing can be done again with the help of the same memory management unit, and the MMU is responsible for determining the victim pages, which pages can be replaced instead of the new pages that has to be brought in. If the pages required by the processor are already in the memory, then there will be no change, it will be getting executed. And if the pages required is not in the memory, then we have to load the page into the memory from the storage. And this should be done while restricted to 2 conditions. One is, we should not let the programmer know that this is happening, and another one is, there should not be any code change. Without this, the demand paging has to be carried out as a background process work. This is very, very important. So, how we can identify whether a page is in the primary memory or in the secondary memory? There is a bit called valid invalid bit. Initially, all the page table entries are set to I. I means invalid, that is the page is not present in the main memory. V means valid, it means the page is present in the main memory. So, it checks for the reference, and if it is V, then it will start executing the instruction, and if it is I, there will be a page fault. A page fault is also a prime concept of demand paging. The processor requires a page and the page is not available in the memory. So, what will happen next? So, the next topic of this is how to handle a page fault. So, before getting on to that, a small example. A backing store consists of nearly 8 pages A to H, and the physical memory consists of only 3 pages, and for those 3 pages in the page table, the valid invalid bit is set to V, and for other bits it is set to I. If a page which is not present in the main memory is required, then the page fault occurs. How the page fault will be handled by the operating system, we will see step by step. The first step is loading the M value variable, and this instruction whether it present in the page table or not. And step 1 is over. The bit is invalid, so it means it is not available in the page table. Then there will be a trap to the OS. Trap means an interrupt to the OS, operating system, telling that I am in need of this page, but this page is not available here. That message will be conveyed to the OS via the trap. Step 2 is over, and next the OS will take care of this page fault. The OS checks the backing store, that is the secondary storage, whether the particular page is present or not. If it presents, it brings it into the memory page, main memory table, and with this the step 4 is over, and it checks for any free frame and occupy that frame. And next, after bringing it into the main memory, it has to reset the page table entry from invalid to valid. That means now the page is available for execution, and after resetting the page table, it restarts the instruction. So, this is how the OS takes care of the page fault, and this takes some system time. Finally, what are the aspects of demand paging? One is pure demand paging. The quote here is, never bring in a page without a demand. So, initially the memory seems to be empty, and only even the first page will be brought into the memory after it is demanded by the CPU. And the second important aspect is the locality of reference. Locality of reference means some simple set of instructions which are present in the same set of memory will be referred frequently. By doing that, the swapping is avoided, and thereby the time consumption will be less. And finally, another important advantage is the hardware support. It is represented by MMU, Memory Management Unit. Since the memory management unit maps the logical address into the physical address, the process is becoming easier. That's all with the demand paging. To conclude, a happy mind is a learning mind. So always learn happily. Thank you.